This is a non-technical intro to generative AI. You'll learn about the evolution of AI capabilities and analyzing the key technological breakthroughs that have enabled modern generative AI models to achieve remarkable performance. You'll learn about the different levels of LLM applications like Q&A systems, chatbots, RAG solutions, and how large language models can be leveraged for downstream natural language processing tasks, and the development of intelligent AI agents. You'll also learn about the potential of large language model operating systems. Abdul created this course.
We call as generative AI is not too old. In fact, it has been just last couple of years. So first, let's take a look at what has changed. How have we reached here in this particular place? And what kind of challenges lie ahead of us. This is very important before you actually start using the tool in itself. Imagine this is like the manual that tells you what you should do with the tool and what the tool is not good for. Without this knowledge, it's particularly very scary to have a tool which you believe could be great, but maybe it is not. I'm not saying that generative AI is bad, but I'm just saying that you need to know how did we get here, and that is the whole point of this particular section. First of all, why the name generative AI? Few years back, whenever we said something as AI, it was mostly a niche within machine learning or deep learning. For example, if you take text, you would have noticed that few years back we had something called NER, that stands for Named Entity Recognition. If you have got a bunch of text like this, named entity recognition would help you find out the named entities. Like Wall Street is a location, $15 is price, 2011 is a date, Amarin Corp is an org, Visa is an org. So this was possible with NLP, natural language processing, using a very popular technique called NER. Named entity recognition. While today you can go ask a question and then it would give you an answer. So even though previously you had text, you were using AI or AI's, let's say, forefathers like ML and deep learning to get something out of the text. So analyze the text, process the text, find out something from the text. But you are not necessarily using it to create new text in itself. And that is where the generative part comes in. You are now generating text rather than just processing text. Let's take another example. The next one is few years back, you were just trying to figure out whether a given image is a cat or a dog. This example can go multi-level. This is a typical classification problem in machine learning. It could be like cancer, not a cancer. Looking at the image, you can say whether the patient has got pneumonia or not a pneumonia. So it could be at any level. But imagine you have got two sets of input, or you have got like, let's say, unlabeled input, and you want to figure out whether the output is cat or not cat, or cat or dog. So it could be of any type. So even in this case, the AI or the deep learning model was purely used to classify an input image. But what has changed now? Now you can actually artificially generate the image of a cat flying from the sky, falling from the sky. You can generate a cat as a president. You can do basically anything that you want. You can generate images as much as you want, and that's exactly why it is generative agent. A new powerful class of large language models is making it possible for machines to write code, write text, draw something, or create something with credible and sometimes superhuman results. Now let's break this down. First of all, we say large language models, but let's say large models. Language is only one aspect of it. We have got multimodal models these days that can do multimodality, that can create text, understand images, generate audio. Like for example, Google Gemini is a great example of a multimodal model. in the open source world, you have got something like Lava, which is a great example of a multimodal model. So either way, we have got a new class of large models, really, really large models. And these models enable or let humans use these models, use these AI systems to write English or multilingual text, code, which is a computer program that successfully runs, draw, create images, and like create bunch of other things like audio, video, 3D, point cloud, a lot of other these things. The main thing here is that one, when something like this happens, the result is credible. Like you can see this and then believe it could have come from a human being. And that is very important. I mean, you could have used AI to create something maybe like 5 years back. I have created, let's say, tweet bots before, like long back before all these generative AI, using a technique called Markov chain. Markov chain used to use the underlying patterns within the text and then try to create the next word very similar like that. Markov chain is a very popular technique that uses states and transition to understand the underlying pattern from the previous pattern or the previous state. But those were not as good as what it is today. Even though we had those things, those were not like actual human text. But now we have models that can create text exactly like how Shakespeare would write a new book or a new play. We have models that can code like a proper programmer. We have models that can create art like, let's say, Van Gogh or some other famous artist. So we have all these possibilities that are credible. When you see it, you have to take a second look just to believe that this is either a human or an AI. And also it can make a superhuman result. What do I mean by superhuman result? A human being would take X amount of time to create something. You ask me to create a Streamlit application. I would take a given amount of time to create that Streamlit application. Given that I'm a human being, I would need an X amount of time to create it. Or let's say you are a human being and you need to create a computer program. You have to take a certain amount of time. You want to write a book, you would take time. You want to create an art, you would take time. But these models are scalable. That means you can write a book in maybe one day. You can create a powerful application like a desktop application, maybe a Python GUI, graphical user interface, in just a couple of prompts. And all these things are possible thanks to these large models that are mostly at this point transformer based architectures. I'm not going to get into the details, but if you're attending a course about generative AI, you should know that most of these models are based on something called transformers, which is a very popular architecture that was popularized or that was at least released by Google, which uses a very important technique called attention. So the attention based transformer model is at the core of all these things. And now we have got language models that can write and code. We have got like diffusion models that can create images. We have got like multitude of other models, in fact multimodal models, where we have got text and images in the same space within the same model in itself. And that is what makes generative AI quite interesting. Look at these images. These are images created by AI. I mean, somehow you could say today that these are AI created images. But if you had shown the same images to me 3-4 years back, I wouldn't have even guessed, even like with enough clue, that these are AI generated images, because not even in my dream I've thought that AI could create something like this. And these things get better and better every single day, thanks to the powerful class of models that we have got, and thanks to the research advancement that is happening every day. And in fact, if you see AI today, the AI is not affecting the blue collar workers. I mean, back in the day, people used to talk about automation. People used to always say automation is going to take the jobs of, let's say, factory workers. Automation used to take the jobs of people who are working in factories and manufacturing units. It did, in fact. There are a lot of information about how Amazon has made most of its packaging and shipping and logistics automated. These things happened, like Tesla's factory. If you see, there are a lot of robots in there. So definitely there was a bit of automation and robots taking the jobs of, let's say, blue collar workers. But has your barber gone out of a job? Has your hairstylist gone out of job? Not yet. But if you see the world of generative AI, it primarily focuses on knowledge workers and creative workers. Knowledge workers and creative workers are mostly people like you and I who are part of this course. We use our knowledge and create something, and that's how we get paid. Either we write English, some other language, we write code, computer program, we create something using an image, or we create an image in itself, we produce an audio or video, or we listen to an audio or video and produce something. So somehow, if you see these knowledge workers or creative workers, either their input or their output are one of these, either text or code or image or video, audio, 3D, point cloud, you can just go on and on. Now, if you see the current state of generative AI models, you can pretty much say that it's 4 out of 5. Like I could have given 5 out of 5, but I still want to say that it's not still there. So almost like 4 out of 5, you can say that these large language models are pretty good at writing, and not multilingual yet. I mean, there are multilingual models, but you can pretty much tell the difference. Like if you, for example, if you ask a model to create something in my language, which is South Indian language, Tamil, you know that, okay, maybe this is not necessarily human because these models are really not that good yet. The next one is code. These models can do pretty much good code. They can create GUI applications, but not to the text level. If you can say the model is good, 4 out of 5 in text, the code part is, let's say, 3 out of 5. Then images. The way the model understands images, the way the model can create images, creating images is really good, but still there are certain aspects. You can look at the eyeballs, you can look at the fingers. I mean, fingers have almost got sorted out at this point, but you can still look at things like that, the skin tone, a lot of other things to tell that maybe this is an AI generated image. The same thing goes with image understanding. Then you have got the video and audio, which maybe, at this point is like 1 out of 5 because it's still improving. The video interlacing, the change of the frames, all frame transition, there is still an improvement. Then there are like other modalities that we don't discussed about at all, like 3D, nerf, point cloud, and all these things exist. But one thing that is very sure, that if you are talking about generative AI, you have to say that the particular set of people that it impacts, whether it positively impacts or negatively impacts, is knowledge worker and creative worker. Previously, it might have taken me, let's say, 3 to 4 hours to create a YouTube thumbnail. But now it takes much lesser time thanks to generative AI. Previously, it might have taken me, let's say, a lot more time to summarize a document. But thanks to generative AI, it takes me much lesser time now. So it positively impacts and also negatively impacts primarily knowledge workers who have to use their brain and either take the output, which is somewhat this. So it has to use one of these modalities like text, code, video, image, audio, etc. etc. Why is that now? We have a huge flux in growth of generative AI. I mean, what has happened? We already discussed about transformers very briefly, that the paper and the new neural network architecture, transformers gave way for all the models that we are using now, or most of the models that we are using now. But there is something else that we need to pay attention to. Now it is the time we have a lot of other things combining together at the same time. So if you see now, we have got better models. We have got different architecture, which is what, like I said, transformers architecture. And in fact, there are transformer alternatives that are coming up called, like, for example, Mamba. These are like state space models, SSM, that solves the problems transformers face in terms of model scaling and time complexity. We have got more compute. Compute has never been cheaper like this. It is completely possible for you to rent a very huge amount of compute on AWS. The accessibility is there. Compute in itself is there. NVIDIA has released almost like a supercomputer level GPU or accelerated computing device that you or I can probably own. Maybe expensive, but still somebody can own. And we have got more amount of data. Historically and all the while, humans have been always creating data. We create data voluntarily. We create data without being asked to create data. You go to a supermarket, you try to pick something. There is a CCTV capturing your data. There is video data. You go to the same supermarket, you buy something. Now that is going to be part of a POS, like point of sale system. That is a data. You come out of the supermarket, maybe you're going to tweet about it. That is the data that you are generating. Maybe there is going to be an Instagram post. That is the data that you are generating. Maybe you have got a loyalty points card. That is the data that you are generating. Maybe you are going to return it. That is the data that you are generating. So there is a lot more amount of data from humans, but also we have more sensors and other equipments that can collect data. There is data from let's say electricity, like sensors. There is data from airplanes, and there is data everywhere else. The amount of images that we have digitized, huge. The amount of books that we have digitized, huge. The amount of unstructured information to structured information that we have moved, huge. So we have now tons and tons and tons of data. And one thing that you can also see is that the models have become better with the model size also. When you have got more data, more compute, the models have started becoming better. For example, Palm, which is a Google model, has got 540 billion parameter. Not saying that you always need a lot of data for a good model. That's not the outcome that you should take. But a lot of data will help you build a good model. And finally, at least for me personally, one of the most important reason why things have gone well is open source, open research, open models, open techniques, open tools. Few years back, you did not have, let's say, a place like Hugging Face where you can go share the model. Few years back, people were not putting out papers almost every single day on, let's say, archive, which they found out. And few years back, you did not have all these scripts that would make it easier for them to build fine-tuning solutions. And all these things are there today, and like for the last couple of years at least. And these are people who have relentlessly open sourced whatever they have created. And that has almost led to a huge influx and revolution of new types of models, new fine-tuned models, new techniques, new data, and a lot of these things exist. So it's better models, more compute, more data, while all these being open source. I mean, compute, of course, it's still not, you've got like decentralized models like Petals. There are solutions, but it is one of the places where it is not open yet. But everything else, do you have better models, open source models, base models? Yes, we have. Do you have more data? Of course, we have got more data. And those data with commercial license and without commercial license, we have got. And the bigger part is all these things are open source. You can go take any model, start building models, or you can take one of the models, start fine tuning it. You can do all these things even without the required computer. Even if you do not have a GPU, you can go to Google Colab for free and then use their GPU and then play with these models, thanks to open source. So all these things come together and then help you create something that did not exist before, thanks to better models, more data, more compute, and open source. And finally, if you have to look at the generative AI landscape, the generative AI landscape keeps on changing, but you can kind of put it into multiple buckets. If you look at the text, primarily people use text for marketing content, sales email, support chat, email support, note taking, general writing. In professional world, I'm not talking about, kids using text for their homeworks. In professional world, code, you can generate code, you can generate documentation, you can understand code. Today you can like literally highlight a particular part of the code, and GPT-4 and other models can help you understand it. You have got image generation for, like, let's say advertisement, voice synthesis, video generation, and you have got a bunch of other things. You have got NPCs inside games that are AI generated. You have got game assets that are AI generated. You have got game scenarios that are AI generated. And you have got multiple companies working on it. One thing that you have to understand is there are multiple layers, multiple different ways you can be part of this. One is the model layer. You're not talking about the data layer in itself. When you go inside model layer, you have data layer. The other side is the application layer. Either you can build applications on top of these models, or you can build the models, or you can build data for the model. And one of the most important thing these days people started wondering is, how do you evaluate the models? Model evals, model monitoring. So there are a lot of different ways you can be part of the generative AI landscape. And when you look at the companies, you have a lot of different companies. You have got Midjourney that can create images. You have got GitHub Copilot that can code for you, that can help you understand the code. You have got tools like Jasper that helps you use for something like OpenAI API and lets you use it for a particular vertical like marketing. And you have got a lot more other companies like Cohere creating models. You have got Hugging Face helping you host and also create models. You've got all these different kinds of companies, all these different kinds of domains, and with a very nice match, you can build things. You can build things either in the model layer, which is like data layer, model monitoring, open source tools, or you can build in the application layer. And when you build an application layer, you can either go to a particular vertical. You can say, I want to build something in sales, I want to build something in marketing. Maybe you want to build a chatbot for lawyers. So you can go to a particular vertical, or you can go to a particular function. You can say, okay, I will take a particular business unit irrespective of what modality I'm using. Or you can go by modality. You can say, I'm going to just pick text and then build something in text. I'm going to pick code and build something in code. So there are a lot of different ways for you to approach this. And if you generally talk about how good AI has become, you can just tell it to write a poem, write a story, or write something, and it is going to do it for you. There are a lot of instances I have given such poems to human beings, and it has been quite difficult for them to know that it was AI written. And they have been shocked to know that this has been AI written when somebody was not exposed to AI. So, one, we have spoken all the things that people are talking about, but there are certain things that people do not talk about often. And those are also quite important for us to pay a slight attention to. One, training data. Two, hallucination. Three, rules. Four, copyrights. Not a lot of time we have training data, which a lot of companies have openly shared. GPT-4, GPT 4.5, whatever the latest model is, we do not know entirely what training data that they used. Generally, they say they used web data. How much of that web data is consent with consent? How much of that web data is without consent? Nobody knows. There are lawsuits. People have always filed cases. People have shared their voice against, let's say, tools like Stable Diffusion, creating artist work. But the point here is that a training data is a place, or training data is a thing with which we don't have a lot of information, and also we don't speak a lot. Open tools, open models have given you some understanding about the kind of training data that goes into with consent, without consent, all these things. But still, even if you take one of the most popular models these days is Mistral, but you don't know what is Mistral's training data. Maybe Mistral doesn't want to get sued, or maybe this is what it takes to build a GPT-4 equivalent open model. The point is, training data matters. Not maybe today. I'm not pro copyright. I'm not against copyright. I'm just saying that imagine you wrote a book, let's say like Harry Potter or something, and there is an AI that can read your book or that has read your book and create a similar work which you may have to take like couple of years to do, but AI is really good at it. Maybe it would hurt. As a software engineer or as a data scientist, I don't know how much I would say. There is a meme, for example, the text that you take from a book, the author would feel sad, or an artist would feel bad when their work is copied by AI. But when they tell a programmer that AI has copied from Stack Overflow and GitHub, the programmer actually says that, okay, that's what I do every day. So our profession, or at least like if you are from a software background or a data scientist, you might feel that, we do it very often. But there are a lot of other professions where creative work is their bread and butter. They get paid by writing books, they get paid by creating art. So I'm not sure what is going to happen, especially when we do not have training data transparency. There are companies like Shutterstock, Adobe have explicitly said that we are going to use only consented data for training our, let's say, image generation model. There are companies that do this kind of stuff, but still it is not an industry standard yet. The next one is the models are quite good at hallucinating. Now, whether hallucination is good, hallucination is bad, that is for a separate conversation altogether. Andrej Karpathy, who is now part of OpenAI, previously the head of self-driving at Tesla, who is a very popular figure in the deep learning world in terms of his teaching and all the things that he shares. Andrej Karpathy has always said, I consider that these models are dreaming, and some dreams are factually right, some dreams are not. And I see hallucination as a feature than a bug. I feel like most of these models are hallucinating, and when the hallucination is right, factually correct, we take them. And the hallucination is factually incorrect, we call it hallucination. So everybody has got their opinion. It is very easy to use techniques like prompt injection or some other techniques and make these models give you a wrong answer. Like for example, in this case, I have basically made ChatGPT to tell me what is Neo's favorite food in the Matrix, and it says according to a statement made by the directors of the Matrix movies in 2021, Neo's favorite food in the Matrix is chicken biryani, followed by Italian pasta as his second favorite. There is no information about this. There was nothing like this on the internet. I primarily injected that information in context to ChatGPT so that ChatGPT would give me this response back when I asked this question, which is completely possible. This is not technically hallucination, but this is like one of the adversarial attacks with which you can make ChatGPT or other large language models to give you factually incorrect answer. So hallucination is a big part of it. Hallucination is one reason why medicine does not use a lot of large language models, because you cannot still rely exactly whether the answer is right or not. The model gives you a different answer when you say let's think step by step. The model will not give you the same answer when you don't say that. There are a lot of memes that you can actually tip ChatGPT, or you can say that my mom likes you, or save the kittens and all the other things, and get a different answer altogether. So overall, hallucination, I don't know whether you like it, whether you don't like it, but it is still part of a problem in democratizing large language models in everyday life. And the next thing is the rules. What is the question for which you want ChatGPT to answer? What is the question you don't want ChatGPT to answer? The main question is who makes the rule? OpenAI has made a rule saying, where do I find cheap cigarette is okay to answer, while how can I create a bomb is a question that I should not answer. Well and good that OpenAI made this decision, but how far and how long you want a for profit, or at least OpenAI is a weird setup. It's a non-profit and it has got a for profit. So anyways, how for how long you want big corporates with, let's say, market interest to make these decisions for you, and whether it is right decision, whether it is wrong decision, every country is different. Some country might have certain beliefs, some country might not have. There is no global belief. I mean, like we have certain global beliefs like kids are cute, kittens are cute. So these are like global belief. Imagine you are a kitten lover. Maybe you don't like dogs. So what do you want the model to do? So there is a larger amount of question about who makes the rules. There are bodies being created. There are bodies being dismantled because it's not working. But at least at this point, who makes the rule is a big question. And that is one of the reasons why I love decentralized AI, and why in this course we are also going to see a lot of local AI, which means like you can run the model yourself on your desktop or a laptop or PC, whatever that you have got. You don't have to always rely on one company setting the rule and then getting the model in itself. I mean, that's one thing that at least I believe, that we need to have a lot of models, and you get to choose what you want to follow. It's like living on this planet. You get to choose your religion, you get to choose your food, you get to choose your dress. You don't have to globally follow a set of rule until you want to be. Nobody should be forcing it on you. That is exactly why we need local open models. And this is a big part of a question, to say who makes rules when the model is not open. And as much as we talk about like good things in AI, it is very important for us to, while we are talking about all the other things, it is very important for us to understand at least the implications that it might bring. The current exam system that we have might be obsolete with the generative AI that we see. I mean, look at the exam results. GPT-4, this is GPT-4 score. This is GPT-4 score. It has scored tremendously in a lot of these exams where human beings have to take. If you have AI models really good, maybe you can hear the model through your headphones or whatever it is. What is the purpose of this exam? How do you now still hold these exams accountable to select the right set of humans for the right set of, let's say, courses or whatever it is? So education plus academia is one of the places where these large language models have got some pushback. There are universities who have punished students for using large language models. There are certain places where universities have encouraged students to use large language models. Khan Academy has signed up with OpenAI as a partner to create a personal tutor for every student. So this is a place where still there is a lot of questions among the academic researchers or educationers or teachers about how do they encourage or discourage using large language models. But the broader question is, how much of what we have followed until now is going to be valid? Already, for example, like if you're in India, you know that in India there are certain institutes where you should not open the book and write the answer. But then there are certain cases where you can have open book. Like you can have any book that you want and you have to figure out to write the answer. So education requires its own transformation, and whether willingly or unwillingly, LLMs are going to transform education for good or for bad. But this is a place where there is going to be a lot of impact in terms of large language models. And we already discussed about knowledge workers. I'll give you a particular example. I am data scientist by profession, and one of the part of my job is sometimes making charts and explaining charts to our stakeholders. And this is something that GPT-4 Vision can do it. Like we'll see a couple of examples. GPT-4 Vision can take a chart like this, help you understand, translate the chart into structured data, and it can do much more efficiently than what I can do. I'm not saying that I'm going to be replaced by a GPT-4 Vision model tomorrow. Maybe that will not happen tomorrow. But what does it mean for my daily job if the model can do a much better job than me at a particular task? Maybe the model still does not generalize well as much as a human I would do. As a human, I might improvise. I might know what to say, what not to say, depending upon who the person is. But the models are getting good at it. And as you can see here, what will happen to the knowledge workers? This is something that people should know. And in terms of copyrights, I think there is a huge debate and issue. There are a lot of lawsuits, cases against Midjourney, OpenAI, and all the companies. In fact, OpenAI has promised that if you use OpenAI product and you get sued by somebody, OpenAI will pay your legal fees and fight for you. That's a huge commitment. I'm not sure how it is going to work or how much it is going to work, but at least for that matter, that copyrights are going to be a big deal. Whether you like or not, the world that we live in, copyrights are a huge part. Patents, copyrights, people get a royalty from these things. Now, one, you are going to put a lot of these professions out of work. Two, it's going to become ridiculously easy to replicate their work. So, what would it mean to have copyright still intact? Is it possible that we are going to enter into a world where copyrights don't exist? But then, will OpenAI or these kind of companies share their code openly because they don't respect copyrights? Then, do they let people copy their work? They're not going to let people copy their work. So, it's a very strange predicament in which these companies are, we are, but we don't have answers. Like, these are like questions that we have got, we don't have answers. If you want to finish this presentation with one final takeaway, I would like to say that generative AI is transformative, disruptive, and unlike, let's say I'm not a very big crypto fanboy, but unlike like let's say crypto or Web3 or blockchain and all the other things, like recently people have been like really getting crazy about, generative AI is here to stay. It's not going to go anywhere. It's not going to vanish. You can pretend that it is not going to impact your job, but it is going to stay. But like every other technology, it has its own limitations. And if not handled with care, it can affect current form of education, it can impact jobs, it can spread misinformation, it can widen inequality. I mean, of course, it has a lot of other good things. I'm not talking about the good things here. I just want you to know before you enter into learning how to use these tools that the tools that we are going to learn about in this course will have impact on all these things. I don't know if it is a nice touch. I said like this is written by a living human. But again, what is written? I typed it on a computer, pasted it here. Even written is being a question. I don't know the answer to, but that has been there for many years. But the point is, it is a very strange place that we are in. If you take like humanity, and that's why a lot of people say AI is like electricity. And I believe if AI is like electricity, then decentralized AI is the way to go. So you use your own AI models and then you build your own things. You don't have to use it from somebody else. I mean, like a lot of countries have only governments making electricity, but then there are a lot of other places. Like if you see Tesla sells solar cells, people buy solar cells, make their own electricity, use it for their own cars, use it for their own stuff. I think decentralization is the way to go about. But in this course, we'll see both the closed models and open models. But while there is a little bit of, or I should say a lot more emphasis on open models, because that is a principle that I believe in. At the same time, a lot of people are also against open sourcing AI because they compare now AI with nuclear energy. And then there are a lot of different ways that they go about. It's two different schools of thought. I'm part of something, like somebody's part of something. If you have any thoughts, I would like to know about what you think about generative AI. See you in another chapter. So the last video ended with me saying that I prefer decentralized AI, but I did not provide any kind of clarification. What do I mean by that? So in this video, I want to first offer what do we mean by decentralized AI, and I want to in fact break down certain things. Before we go ahead with decentralized as a part, let's define what do we mean by AI here. So as you all know, of course, AI is here artificial intelligence. We are not talking about AGI, which specifically talks about general intelligence. So here we are talking about narrow artificial intelligence, which is AI. Now, what is this AI? Why is everybody talking about AI? We saw a glimpse of this in the previous video, but now the AI here, specifically, if you're talking about technically, is nothing but deep learning problems. What are deep learning problems? Deep learning is a computer science domain where you build deep neural networks. So typically a neural network would look like this. It has got an input layer, a middle layer, and an output layer. This is typically how a simple neural network would look. But if you replace the middle layer with a lot of deep layers, that is basically what your deep learning is. Now, for you to do deep learning effectively, you need parallel computing or you need high memory, because at the end of the day, what is happening in deep learning is it is matrix multiplication. It has got a lot of different weights within this neural network. So if you see here, you have got a lot of different weights here, and these weights get multiplied, certain things happen. So at the core, what you need is you need really good compute that can do matrix multiplication for you. And for that particular reason, deep learning is more efficient on GPU than CPU. Now, what is GPU? GPU stands for graphical processing unit, and CPU stands for central processing unit. Your normal computer or the laptop or probably the device that you're using right now has mostly got both GPU and CPU. Does it mean you can do deep learning on any device? That is where a big catch comes in. See, most popular frameworks for deep learning, or at least one of the most popular framework for deep learning today, is called PyTorch. Now, PyTorch and many other deep learning frameworks are primarily optimized or efficient on NVIDIA GPUs. NVIDIA GPUs are really one of the core of why deep learning exists or deep learning happens, or where deep learning happens these days. Now, the reason why NVIDIA GPU is highly preferred is primarily because NVIDIA GPU has got their own proprietary software which they call CUDA. So CUDA is the software that is one of the primary reasons that enables parallel computing, like high level parallel computing within NVIDIA GPUs to efficiently utilize the NVIDIA GPU memory and then do matrix multiplication or do deep learning efficiently. Thanks to CUDA, NVIDIA GPUs are the home for most of the deep learning projects. It doesn't mean you cannot do it on CPU. It doesn't mean you cannot do it on AMD processors. It means NVIDIA is highly preferred. Now, what is this CUDA? So the CUDA, or it is an acronym for Compute Unified Device Architecture. It is a proprietary, that is one thing that people often forget. It is not an open source solution. It is a proprietary closed parallel computing platform and an API that allows softwares to use certain types of GPUs for general purpose processing. So what we are doing here, the matrix multiplication we are doing is a general purpose processing. And for that general purpose processing, we are leveraging the GPU. And this approach is called GPGPU, general purpose computing on GPUs. So CUDA is the software layer that gives direct access to GPU's virtual instruction set and parallel computation elements for the execution of compute kernels. Now, what CUDA enables you to do ultimately is do this better GPU or leverage GPU for matrix multiplication. That means you can do machine learning and deep learning. Having said that, that basically enables most of this AI models to effectively run primarily on NVIDIA enabled GPUs. So if you want effective hardware for running deep learning or for running AI, you need effective GPUs. And not everybody has got effective GPUs. And that is where a lot of other concepts come into picture. So now first thing is, because you need effective GPU, that is clear at this point, right? Deep learning, here we are saying AI basically we are saying it is deep learning, and deep learning mainly prefers GPU because of compute and memory. And frameworks like PyTorch lets you do that thanks to CUDA, maybe not so much thanks because it's not open source, and you need all these things. So that is where running an AI model or an LLM becomes a little challenging. So if you want to run an LLM, so if you want to run an AI model or an LLM, let's say you want to run an LLM, in this case, we are referring to large language models. So if you want to run large language models, let's say now you at this point need NVIDIA GPUs. No, because of this reason, because it is very expensive computationally, you don't often use NVIDIA GPUs as a physical hardware. Rather, you would rent this on a cloud provider. So you would go to, let's say, AWS, you would go to GCP, or you would go to Azure, and then you would rent an NVIDIA GPU. This is option one. Option two is, these days you have got a lot of new startups, like for example, one of the most popular one is RunPod. So you can go to RunPod and rent a GPU. So GPU, there are like different kinds of GPU. For example, RTX, let's say 4080, 4090 is a very popular GPU. A100, another popular GPU. These are like on a different levels. It has got different memories. It has got different compute. The flops would be different. A lot of things are different. So now, one, you can go to these cloud platforms, rent a GPU, or you can go to this new kind of computing or cloud platform and rent a GPU. This is where you could do this machine learning or deep learning or whatever LLMs efficiently. Now, what do I actually mean by, do LLMs? I've been saying that do LLMs. What do I mean by do LLMs? That is a very important thing for us to note, because LLM doesn't happen to be just like that. There are a lot of steps in building an LLM. First thing, you need to prepare data set. So you need an input data set that you can use. And these data sets, because we are talking about large language model, we are not talking about just a simple language model. We are talking about large language models. These large language models require you to have large amount of data set. So because of that only, you end up having large language model. And because you need data set, you need preparation, which you can still do it in GPU, but CPU, still you need like GBs of data, like gigabytes of data. After you do that, the next thing that you need to do is you need to train a model. Train a model is what we call as building a model. Once you build a model successfully, sometimes you might do an evaluation to see how good the model is doing. So you have got a bunch of evaluation metrics or benchmarks to see how the model itself is doing when you compare it with different models. So you need data set, then you train a model, then you eval or do benchmarks. Now, what started happening in the deep learning world is some years back, before that, there was a new technique that came into picture that is called transfer learning. So what this technique said is that, okay, not everybody has to build their own model. I'm not talking about LLMs here. I'm talking about any deep learning model. Rather, you can take certain pre-trained deep learning models and then you can use that for your own use case. So you take a pre-trained deep learning model and you use that model as your base model, and then you do something called fine tuning for your own use case. And then you have a new model, and that model is supposedly better than the pre-trained model for your own use case. If pre-trained model was something, this model, after you fine-tuned, would be better than what the pre-trained model was for the fine-tuning task in which you did it. Now, this has been there for quite a while. So now, when we have to build a large language model, we need data set, we need to train a model, and we know that if we have to train a model, which is basically building a deep learning model, we need GPUs. And then you do evaluation or benchmark. After you have a model in place, let's say at this point you have a model in place. And what is that we mean by a model? So most of the times, what we mean by model is a PyTorch bin file. So it's a .bin file, or sometimes these days we have safe tensor files. So we have safe tensor file or we have PyTorch bin file. These are the files where the deep neural networks weights are stored. At the start of this video, I said, like, there are weights, like numerical weights that are stored here. And these numerical weights are mostly float. So these numerical weights are mostly floats. What do we mean by float? It's like 0.2678996, something like this is a floating point. So we have numerical weights, and these weights are stored inside this bin file or safe tensor file. Now, when you have a longer number here like this, very long number, you need more memory to run the model also. Forget about training the model. Even to run the model, you need more memory. And what is that is called? That running the model is called inference. So inference means you use the model to generate text. We're talking about LLMs particularly here. So using the LLM to generate text is called inference. So at this point you need GPU to run create the model. You need GPU to also run the model. That is what is inference. But because not everybody can have CPU, there are new techniques like, for example, quantization. There are different kinds of quantization techniques, but in a nutshell, quantization helps you reduce the precision of the floating points that you store and thereby reduce the memory that is required for inference so that you can run this inference on even consumer hardware GPUs or even CPUs. So we have quantized models. We have quantized models that help you run these models on consumer hardware, either GPU or CPU. And one of the most popular frameworks for that is Llama CPP. And there are many other techniques like file formats like GGUF, GGML. You don't have to know exactly what is inside this and all these things. You just have to know these names so that you know what, when you come across this name, you know this is basically quantized model. So you're going to use Llama CPP, that is going to help you convert the model weights into, let's say, a C++ quantized weight, and that helps you run the PyTorch code. Basically is ported into C++, which is like much faster than PyTorch, and then it uses different file formats which has quantized model weights, and then you can run the model on consumer hardware like your laptop. So now, because we spoke about CPU and GPU and we have seen about quantization, let's take a quick look at a bunch of things. So we know CPU and we know GPU. In GPU, you have multiple providers. You have NVIDIA, let's say, a very popular leader. You have AMD and you have a bunch of other companies. And then you have got TPU. The T in TPU stands for Tensor Processing Unit. This is primarily mostly used by Google. So Google has primarily got TPUs. I'll quickly show you Google Colab and you would see TPUs there. And very recently, there is another popular one that is coming up that is called Metal. And what is this Metal? It is nothing but Apple Silicon computers. So if you have got M1, M2, M3 computers from Apple, it could be MacBook Air, MacBook Pro, Mac Mini, whatever computer you have got. If you have got any of these chips, it is highly likely that you have got Metal GPU within this Apple Silicon. And these days we have got frameworks and softwares that can let you run these deep learning models optimized for Metal. So these are like different kinds of computings, and these are like, what you can do. Now let's take a quick look at different kinds of frameworks. We learned about PyTorch, but PyTorch is not the fastest one. So there are people who have fallen back to something called JAX. And very recently, Apple announced something for MLX, and this is primarily optimized for Apple Silicon. So, but most of the things that you would see on PyTorch, you have got JAX, and still some people port things into C++, and you have got MLX very recently that is optimized for Apple Silicon. I know this is a lot of information in this video, but the objective of this video is to give you a very wide landscape idea about what is like the technical details of what we call as large language models. And I hope you have some clarity about what we mean by large language models. To quickly recap, when we say large language model, the model here is nothing but a deep learning model. A deep learning model is nothing but a deep neural network. So it is like quite deep, and then it has finally an output. And most of the large language models that we are discussing today are large language models based on a particular deep learning architecture that is called transformers. So transformers is one of the most popular architecture based on which these deep learning models are built. And we know that we need GPU to run these deep learning models. And when we say GPUs, we are primarily talking about NVIDIA GPUs. And because we don't have NVIDIA GPUs like lying around in our house, most of the people, if you have got, you're lucky. But if you do not have, that is where you go to a cloud provider and either rent a GPU, or you go to some other cloud provider and then try to use one of their services. And because of this primary reason, because GPU is computationally expensive, GPUs are hard to get, and not the highest model, not easy for you to run on CPUs. Because of this primary reason, people offer LLMs as inference APIs. We already learned what is inference. Inference is the process of running an LLM and then getting the text output. So building an LLM is one, running an LLM is what we call as inference. So because of all the bottlenecks you have got, because of all the reasons that it is difficult to run a large language model, also you have to run it in production, which means you need GPU always. You may not have serverless compute. That means you always have a cold start problem because you have to boot up the GPU. To solve all these problems, a bunch of companies decided to give the LLM as an inference API. It's not first time somebody is doing it. Software engineering is quite popular with the API world. But if you are new to the API world, API stands for Application Programming Interface. It's nothing but a connection to a bigger system. That system would be owned by somebody else, and you are going to just hit their endpoint and then get a response back. So you're going to hit their endpoint and get a response back. Now the challenge here is that if you are working in a big company, if you are working in an enterprise setup, especially if you are working in, let's say, finance sector or healthcare sector, not every company would be interested in giving your data to somebody else, because there is a server and you are going to hit that API from that server and then get the response back. If you want to, let's say, design an app, you will not have your own GPU to run, one. Second, you cannot run that app. I mean, now you can do it with iPad Pro because it has got Apple Silicon, but mostly let's assume you cannot do it. That means you definitely have to hit an endpoint, API endpoint, and then get the response back. That means you're sharing the data with them. And that is where a whole new business of how you can use LLMs as an API comes into picture. Without any doubt, the leader in this business is OpenAI. OpenAI, if you are wondering how does OpenAI make money, OpenAI makes money because their model is not open source. Not everybody can host it. That means if you want to use GPT-4, one, you can go to GPT-4, the chat GPT, and then use it. But you cannot build softwares on top of it. You can chat with it, but you cannot build softwares on top of it. And if you want to build softwares on top of it, let's say you want to build your own translation software, or let's say you want to create your own design software, or let's say you want to create something only for lawyers, then that means you need to create an app either on web or like let's say iOS. That means within this, you have to hit the OpenAI endpoint and get the response back. And it's not just OpenAI is the company that is alone doing this business. OpenAI is definitely one of the leaders in this because they have got the exclusivity and they are the best LLMs in this world at this point. Their GPT-4 is definitely the best LLM at this point. Generally, there are like specifically you would go to different LLMs, but generally this is one. So OpenAI, no brainer. Then you have got Azure, then you have got AWS Bedrock, and there are other services like this that, in fact, like let's say Google GCP, because Google has got Gemini and bunch of other things. Palm, let's say Palm. These are like model names. So these service providers also let you use a large language model as an inference endpoint, API endpoint. The challenge is most of them would not let you fine tune it, even though OpenAI recently started letting you fine tune as well. So if you want to, let's say, just have a chatbot, the easiest way to do that is build an application where take a user response, hit the OpenAI endpoint, get the response back, show it to the user. You have a working chatbot without having to maintain your own infra, or GPUs. But if you are worried about data, let's say data challenges, data privacy, and lot other things, that is where the whole new concept of open models come into picture. Instead of owning a proprietary model, instead of paying money to an LLM service provider who owns a proprietary model like OpenAI, you would turn towards open models, which means the model weights. So the model weights, you all know what is model weight. Let's say the .bin file, the PyTorch file, or the safe tensor file, or openly shared. When we say openly shared, it comes with a particular license. I'll get into the license detail later on. But these are model weights which you can self-host. You can buy your own small, let's say VPS like virtual private server, or you can have your own cloud model, and you can have these things and you can host these models and then you can run it. Now this is where open AI versus truly open AI come into picture. This is the company in this case, and this is the open models that you are either self-hosting. Now there are different service providers who let you use these open models, also API, that is a different topic altogether. But in a nutshell, you have got one world which is like proprietary models, the second world where is open model. And what I meant by decentralized AI is using these open models without having to rely on some proprietary model where you have to always send your data to them. Now, like I said, even this model, if you have to self-host it, you need GPUs, or you need to rent GPUs, or you need to use quantized models like GGUF. Or the other option is you go to new providers who let you use this model. And there are a bunch of advantages in using this model, but I want to stop this video here at this point to give you a breather. If you have reached this point at this point, I would strongly encourage you to write a blog post about whatever that you learned in this video, and then write the blog post, publish it anywhere that you want, and then tag me whenever you share it on social media. I would love to read what you have done, because what I have done in this particular video is I've given you a lot of keywords, I've given you a lot of seeds, but if you have to understand this entire space better, you need to spend at least an hour or two in going through these individual keywords that I've given you, so that you can understand this entire landscape and then build a better understanding before we go on to further lessons. See you in another video. 5 levels of LLM apps. Consider this to be a framework and help you decide where you can use LLM. There are a lot of different myths around what LLMs can do, what LLMs cannot do. Where do you use LLMs today? So I decided to put together this material in which I'm going to take you through kind of like a mental framework based on the extension or the depth in which you go towards an LLM. You can decide where you can fit this LLM. So we're going to first see what are those different levels of LLMs that I have put together. Then we are going to see slight extension of that. Got 2 different documents to take you through that. So this will give you an idea about how LLM is being used today and how you can use LLMs for your own applications. To start with, imagine this pyramid structure. This is a very simple pyramid structure. And as you can imagine with any pyramid structure, the top of the pyramid or the peak of the pyramid is our aspirational goal. And what you see at the bottom is the easiest that we can do. And as with everything else, you have to slowly climb to the top of the pyramid so you can probably hit the aspirational goal. So to start with, where do we use LLMs first? Q&A, a question and answering engine. What do I mean by that? It is quite simple for us to understand. So question and answering engine is a system where you have an LLM and all you are going to ask the LLM is a question. So you send a prompt and the LLM takes the prompt and gives you an answer. That is it. That is the entire transaction that you have between an LLM. Send a prompt, send it to the LLM, get an answer. LLM, large language models, are nothing but sophisticated next word prediction engines, and they have been fine-tuned with something called instruction. So they're instruction fine-tuned models. That means they can take a human instruction and get you an answer back. For example, if I ask a question for this, what is the capital of India? Then the LLM would process this, and then LLM has information about how to answer it, and then it will give me the answer back. The capital of India is New Delhi. That's all what you're going to do with this thing. So first level, question and answering. Now you might wonder at this point that where can you use question and answering as an LLM engine? This is the first thing that people built, like when LLM started, even back in the day, GPT-2 level, people started building simply Q&A bots. So all you want to do is ask a question, give an answer. Could be a homework, could be a general knowledge question, could be something about the world, could be about science, could be about anything. Ask a question, get an answer. As simple as that. It's a very 3-step process. Ask a question or send a prompt, take the LLM to process it, give me the answer back. Very simple application. Now what you're going to do is you're going to add something to that application, And that is how you actually build a conversational chatbot. And to understand this better, I would like to take you to my second document, which will give you probably better idea. Whenever we are talking about LLM, there is one important thing that we need to understand is we have crossed the stage where LLM is simply a large language model. We have more than that. So for you to understand that, I have 5 dimensions: a prompt, a short-term memory, an external knowledge, tools, and extended tools. If you think of this as your horizontal, these are your verticals. These are different dimensions that can add to an LLM. So you have a prompt, you have a short-term memory, you have a long-term memory or external data, you have tools, and you have got extended tools. So let me give you an example for each of this so that you can understand this better. A prompt is, what is the capital of New Delhi? That's all the prompt is. You simply go give what is the capital of New Delhi, and the LLM understands it and gives you a back understanding, just gives it back. Now, short-term memory is when you have conversational history or something in the LLM. That is what we call as ICL, in context learning. So whatever you stuff inside the context window, the LLM can take it. That is your short-term memory. So you give a few short examples. You give an example, like for example, what is the capital of US? I guess it's Washington DC. And you give a bunch of examples like this, so the LLM knows what is that it has to answer. This is a short-term memory. Next, you have external data. Now you take data from Wikipedia and you keep it and then give it to the LLM. That is your long-term memory, because short-term memory, just like a computer, the RAM, it gets reset every time you reset the conversation or the session. And then tools, you let LLM use tools like calculator, internet, Python, terminal, and all these things. And extended tools is when you expand this much beyond that. I hope now you have understanding about the 5 different dimensions that we have in LLMs. A prompt, a short-term memory or in-context memory, a long-term memory or external knowledge, external data or custom knowledge, tools like calculators and Python REPL, and extended tools that goes much beyond that, what we do not have currently. So these are different dimensions. Now coming into what we wanted to see is chatbot. So how do you make a Q&A bot as a chatbot is very simple. Now at this point you might have already got this idea. So you take a prompt and you give it to the LLM where you can have short-term memory, in context memory and in context learning. For example, so what is the capital of India? So what is the capital of India? You ask, and the LLM answers New Delhi. This is what happens in a simple Q&A bot. But how do you make it a conversational bot or a chat bot? By adding a new dimension called a short-term memory. And how do you do that? You keep all these things that you're conversing into the chat conversational history. So what this gives the ability for an LLM to do is, when you say what is the capital of India, it says New Delhi, then you can just simply go and say what are some famous cuisines there. So at this point, the LLM would have an understanding you're talking about New Delhi, because that conversation is stored there in the LLM's short-term memory or the in-context memory. So the LLM can do something called ICL, in context learning, and give you the response back. And that is how you upgrade in the pyramid, by building a Q&A bot, giving a new dimension called history, and then making the Q&A bot a chat bot so that it can converse. Now, chatbot has applications everywhere that you can turn towards. You've got chatbot in customer support, you've got chatbot on websites, you have got chatbot for education, like you've seen a lot of demos from Khan Academy. So chatbot is quite versatile. It almost has its purpose in every single business or domain that you can think of. Now, people were using chatbot, but chatbot itself is not enough. Why? We already know the answer to the question. Can you pause and answer if you know the answer? So why is that chatbot is not enough for a lot of use cases? The answer to the question is, chatbot stops with only short-term memory. You need long-term memory, or you need external memory. See, for example, I ask what is the capital of India? It says New Delhi. What are the famous cuisines there? It will give me an answer. Quite valid. LLM is doing its job. So let's say I'm a company. Okay, so I'm an organization. Let's take Apple for an example. Okay, now I ask who is the CEO of Apple? Of course, the internet has information about it, so it will say Tim Cook. That's quite easy. Now, if I go say who is the manager of the team handling iPhone 16, will it answer? No. I mean, it might answer because it hallucinates a lot, but the answer would not be correct. And that has become a big bottleneck in a lot of enterprise use cases, because you do not just need internet knowledge, you do not just need the knowledge that the LLM has got, you need more than that, and that is the custom knowledge component or the external knowledge component that you need, the dimension that you need to make your LLM slightly more than just a chatbot. And that is where a new technique called RAG comes into picture, retrieval augmented generation, where you use the knowledge that you provide, or you call it a long-term memory. You use the documents, the internet, the sources, everything that you have around, and you use that knowledge to send to route to LLM, and then make the LLM use the leverage that knowledge. And now at this point, probably you might have guessed it. See, first we had only prompt, 1 dimension. Second, we had short-term memory, 2 dimension. Now we have external knowledge, which is 3 dimensions. So this LLM is at the center of 3 different things. You have got prompt, you have got short-term memory, and you have got long-term memory. To make you understand this better, so I'm going to take you to the RAG. So how does a RAG look like? So you have got the LLM at the center of it. You have got your data somewhere available. So it could be on different structures. It could be on database. Most organizations have data in their database, structured database, RDBMS database. Then you have got documents which are unstructured, like PDF, HTML files, internal portals, blah, 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 blah. Then you have got APIs. Let's say you are a sales team, probably your data is in some CRM or Salesforce, right? So you need a programmatic call to make the call and get the answer back. So your data could be of these different places. Could be like structured database like RDBMS system. It could be unstructured documents, PDFs, HTML documents, anything that you have locally. And then you have got programmatic access, like you're a marketing team, you need data from Google Ads. You're a sales team, you need data from Salesforce. Your company is heavily into IT, so you need data from AWS, like billing cost and all other things. So this is programmatic. So you use one of these methods, a structured parsing or unstructured parsing, a programmatic call, and take all the input data and create an index. An index is what Google creates at every single moment. You have got all these websites. What Google does is Google creates this index. So it is easier for Google to go traverse when somebody is asking a question, and that's how Google became popular. Before Google, people were using totally different thing. Google came up with something called PageRank algorithm. At the fundamental of PageRank algorithm, you have got this index with the different parameters, of course. And definitely we are not building Google. But so index is what we are building. It makes it easier for you to understand what is inside the data. So now a user comes in, asks a question. What is the question? Who is the manager of iPhone 16 team? So that question goes to the index. This system, particular system, takes that and picks only the relevant information. See, this index might have information about all the teams. iPhone 16, Apple Vision Pro, billing, accounting, procurement, marketing, blah, 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 blah. So it has all the information. What you are interested in is only this particular piece, which is what you asked, which is iPhone 16 manager. So this particular part is where it takes only the relevant information from the index, and then it matches with the query, the prompt that you give, and then it finally sends it to the LLM. The prompt, what you asked, and the data that you extracted, and it goes to the LLM. LLM gives the answer back to the user. This is quite different from the chatbot application. If you see, I'll give you an example why. So in the chatbot, all you are doing is you have a memory, question is there. Sometimes you might do, let's say, a long-term memory by doing user profiling. I'll ignore this for now. You don't have to use this now. Ignore this for now. So what you're doing is you have a question, you're sending it as a prompt, and you have memory that also goes to the prompt, because that's how you can do it. And you have LLM answering this question and you get the answer back. Now you might ask me, hey, why do I need to put my thing in the external data and create an index? Rather, why can't I keep it in memory? If you have got this question at this point, that is a very important question and you are thinking in the right direction. In fact, people who reached at this point, you can tell me whether you know the answer or not. The reason why we cannot do this or we could not have done it early in these days of LLMs is due to an important factor called CTX window. What is CTX window? CTX window is nothing but called context window. This internal memory and question, or the short-term memory and the question, is bounded by what is the context window of this particular LLM. So you have an LLM. The LLM might have context window like 4K, which is quite popular these days, or 8K. And even Gemini like LLMs have like 1 million as context window. So context window is there. Now what you are actually doing here is you have a question, the LLM answers. So you have a question 1, right? And answer 1 comes back. Then you have a question 2. Then you have answer 2. By the time you go to question 3, what you are sending to the LLM is not just your question 3. You are actually sending all these things, right? So let's say this is 2K. This is 1K answer. Then again 2K question, 1K answer. And let's say this is a 2K question. So at the end of the day, when you are hitting the third level of conversation, I'm kind of exaggerating, but let's say 2 plus 3, 2 plus 1, 3, 3, 6, 8. So you've already hit 8K. So conversation context window. So if you have got 8K token model, at this point, your model will hit out of memory error, or it cannot hold it in short-term memory. And that is exactly why you need RAG, retrieval augmented generation, because this one is not bound by the conversation. Of course, you are going to keep it in conversation, but you don't have to stuff everything inside your question. Rather, you can keep it inside your index, right? Because you've already indexed and you can keep it. And only the bit that is relevant comes to you. And now you might be asking, how is that possible? And for that, you go into like a separate tangential side that talks about semantics and semantic search and all the other things, embedding semantic search. That is quite out of scope. If you want to go deep, you should read RAG. Llama Index is an excellent library for you to read about RAG. They have got a really good developer relation system. They have got a lot of articles and you should definitely read about Llama Index and RAG if you want advanced RAG. But I hope you get the point. Going back to our system that we put together. So what do we have? We have a Q&A system at the front, which just takes an input, gives an output, nothing else. Then you have got the chatbot, the input plus history goes together. That is always short-term memory. You get the output also goes back to the input. That's why you keep the conversation history. Then you have got a RAG, retrieval augmented generation. The reason why it is called retrieval augmented generation is because you have got a retrieval component that you augment with the LLM component and then you generate the response back. So that is retrieval augmented generation, and the applications are enormous. There are a lot of startups in 2024 when we are recording this, a lot of startups just doing RAG. So if you can build a RAG solution today in 2024, you can probably even raise fund or you can be a good successful SaaS. There are a lot of companies making really good money, solid money out of it. I'll give you an example. In fact, like one thing that I've seen, sitegpt.ai. If you go to sitegpt.ai, it says make AI your expert customer support agent. And I know this is a product that is making a lot of money, hundreds and thousands of dollars. And at the foundation of it, it is a RAG. It takes all the information that is available in your website, indexes it, or we call it data ingestion and indexes it. And when you ask a question, it just gives you an answer back. That's it. It's not just a normal chatbot. It is a chatbot that can answer based on the existing data. So if you are breaking into LLM today, I would strongly encourage you to do some RAG system. That is by default something that you should do. So if you're a university student watching this, if you're an early in career professional, I would say you should build a couple of RAG examples so you know. There are a lot of nuances in RAG, like how do you improve indexing? How do you improve indexing by changing chunking? What kind of algorithms you use for embedding and what kind of models are good with RAG? Whether you put the text at the top, is it good? Whether you put the text at the bottom, is it good? If the text is in the middle, it is good. There's a lot of components to RAG. RAG is not just simply what we discuss usually on this channel. You can go advanced RAG, and I would strongly encourage you to spend some time in RAG, unless you want to get into something that is quite exciting and interesting. But before we do that, I would like to quickly show you one more thing that not a lot of people discuss when we talk about LLMs. It is not necessarily RAG, it is just like using short-term memory, so it doesn't use long-term memory, but it has its own potential, which is to use LLMs, large language models, for classical NLP tasks, classical NLP downstream tasks. For example, let's say you want to build a text classification system. What is a text classification system? You give a sentence, for example, the movie was complete crap. Now, is it positive or negative? Positive or negative? You choose, you build, you train a text classification model just to figure out this. For example, or the other example I can give is you have a review. Let's say the movie was amazing and the actress was exceptional. Now, you try to build a model that will say, what kind of review is this? For example, is this review about movie, theater, or a director, or actor? So now you know this is an actor based. So this is what text classification in classical NLP is. There are a lot of other tasks that you do in classical NLP. What you can do is, without having to build your custom model, like let's say BERT based model, XGBoost based models, you can use LLMs, large language models, for classical NLP problems, because large language models are really good in context learning. And with the current memory that you have got, with a few short examples or a tree of thoughts or a chain of thoughts, you can make your large language models a good zero-shot NLP classifier, or it is applicable for a lot of other tasks as well. So one thing that not a lot of people are exploring, I would encourage you to explore if you work in classical NLP problems like labeling or a text classification, entity recognition, whatever it is, you can leverage LLM. Now the question is, do you want an LLM based solution? That's a different topic. I'm not talking about, you looking for a nail because you have got a hammer. I'm just saying that this is a good opportunity. Wherever you don't want to build models, you can use this. But of course, if you can build models, that will be probably cheaper than, making calls to LLMs and getting answer back. But summarization, text classification, entity recognition, I think LLMs are exceptional, zero-shot LLM and downstream tasks, and you should definitely leverage it. Now, with this, we have arrived at RAG. Okay, so we have arrived at RAG, and we already know what is RAG. Now we are entering into a very interesting phase about what everybody is obsessed with, what everybody's love: agents. Very recent announcements from Google, Microsoft, previously OpenAI. In every announcement, you would have seen two important things as a common trend. One is you would have seen multimodality. Multimodality. What does it mean? It just simply means instead of just chatting with text, you can chat with images, you can ask questions in voice, it can respond back in speech, you can send videos. So one important trend that you're seeing is multimodality. And the second important trend that you see everywhere is agents. Multi-agent setup, where you have got multiple agents, you can summon these agents to do certain tasks, and these agents will do it for you. Just like Men in Black, MIB. They have a purpose and they will do certain tasks. But before I jump into agents, I want to actually introduce you to another important concept called function calling. Function calling is the precursor to LLM agents. In function calling, what you do is you have a short-term prompt. You have short-term memory. Sometimes you need external memory, sometimes you don't need external memory. But you are giving the ability of calling external tools. And you are giving the ability of calling external tools by doing something called function calling. Function calling, to be honest, is a terrible name, because you're not calling any function here. You're not making the LLMs call anything, not at all. All you're doing is you're forcing the LLM to give a structured response back so you can call an LLM. I'll give you an example what is function calling. So let's say that you have a weather API. Okay, weather API. I think everybody goes with weather API, so I'm going to skip. Let's say you have a currency converter. Okay, currency converter. What kind of things a currency converter need? Okay, you need input currency, you need output currency, you need date, you need amount. Technically, these are the 4 things you need. What is the amount that you want to convert for? What is the input currency? What is the output currency? And what is the date for which you want to do currency conversion? Let's keep as a simple API. Now, typically when you go to an LLM, okay, and say, what is USD to INR today? First of all, LLM may not understand what is today. LLM might know USD, LLM might know INR, but LLM's memory is frozen because it's a snapshot. See, a large language model is a snapshot. So its memory has been frozen to, let's say, September 2023 or something like that. Okay. So what it cannot do is it cannot give you the latest information. And you cannot do this with, you can do this with RAG, kind of like you can every day take knowledge, ingest, keep it in your memory and then give it back. Not very efficient. Expand this to stock market, daily data doesn't matter because everything changes like every minute and every second. So you need something instant. What do? You call an API. If you're a programmer, that's what you would naturally do. You call an API. Now, if you want to call an API, what you need to call an API. So let's say this is the information. What I need at the end of the day, I want to call it currency converter, right? And I'll say input, output, date, amount, right? I need to make a call like this. So I need 4 arguments that is a solid. Input could not be like, oh, United States, dollar, and some other time I'll be like USD, some other time I'll be like US dollar. That will not work, right? You need a specific format for everything. Your, let's say, amount should be an integer, right? This should be a date object. So you need to force this LLM to give you a particular response back. Otherwise, what happens is this LLM will throw you anything. For example, what I want to say is, what is USD and INR? So I'll be like, oh, USD and INR is so on September 2023. So you have to guide the LLM to make a particular type of output. And somehow universally everybody has accepted that format is going to be JSON, except Anthropic, which absolutely loves XML. So if you use Anthropic, you use XML. If you use any other model, you use JSON. So you're forcing an LLM to give you a structured response back, a JSON that can help you make this function call. You can call this function with that JSON. So a guided response into a JSON is what everybody calls function calling. You don't necessarily call the function in function calling, but you get the output that will help you call function call, right? Clear? Now that is exactly what is a precursor to agent, because in a function call, you have the ability to call a function, and agents are nothing but a bunch of function calls stitched with tools. So what do we have in agents? We have a bunch of function calls plus tools. And I would like to introduce to you a very interesting solution that can help you understand more about agents. If you're too old in the AI world, you would have probably recognized this immediately. And this was the workflow of something called Baby AGI. So Baby AGI was quite a popular thing back in the day. Back in the days, like less than 1 year before, I guess, or maybe more than 1 year. A function call is what I said is the foundation of agents. But what is an agent? Now, if you have seen our pyramid, you would know our agent sits right at the top, like closer to what our aspirational figure is. Now, what is this agent? How do you define an agent? So it's simple. First of all, a chatbot and a RAG, all of these guys, if you see here, they end a text or some kind of thing like input, output, images, video, all these things, right? That's where they end. One of these modalities, they're done. What you achieve with agent is something that is absolutely stunning. You don't stop at text response, you stop at an action. You trigger an action. And that is what agents are simply. You take LLM, you connect them with tool, you give them a purpose or a goal. That is your agent. And that is exactly what baby AGI has done back in the day. Like there are multiple agents now, but if you see baby AGI, which is a very wonderful framework, you can see that there is a task, like there is something that has to happen. There are certain tools, like for example, Vector DB and all the other things are there. And every agent has a purpose. Like, okay, you have to execute, you have to return, you have to do something, you have to do something. And they have a goal. So you have tools, purpose / goals, and LLMs. And this all together work for a common goal. And that is your agent. There are multiple agent frameworks that are quite popular these days. Crew AI, LangGraph, you have got a PyAutogen, and most of these things you will see. First, you have to define a role. You have to define a role, goal, and then you have to say which LLM that you want to use as a backend engine. And then you put together a system of one. This is single agent. Now you put together like this is a team, that is your multi-agent setup. With agents, people are doing amazing things. You can make an agent book your ticket. You can make an agent, let's say, read something, distill something, create a note, publish the blog post. You can summon these agents to do a lot of things. And personally, for me, the most time that I spent reading about agents, because it's becoming quite obvious that agents are the next frontier in the way we can take LLMs forward. I mean, there are a lot of different things, but at least personally, I'm quite interested in automation usually. And I think agents are going to be the next big thing currently itself is a big thing. Google has got Google's own projects, like they call their own agents. I don't know what they call. They have a lot of different names. OpenAI has its own agents. And every time you talk to some company, you speak about agents because you want to summon these agents. You want to connect these LLMs to like different dimension, and this dimension that what we are connecting is the tools dimension. So you take LLMs, you have the function calling ability, and once you connect them to tools, you are unlocking the potential of something immense, and that is what you call as agents. I'm not going deep into agents because this is probably, I'm hoping it to be a series depending upon how you all like it. But in this series, my next focus is going to be agents. So agent is quite closer to the top, and that takes us to the almost the end of the video, which is what is our aspirational thing? What is that we are all trying to go towards to, which is LLMOS. And this is inspired by Andrej Karpathy, who created this amazing structure. So what is happening here? This talks about using LLM at the center of a conversation, or center of an operating system. If you go back in the day, computer was created just for simple calculation purpose, right? You want to add A and B. You want to keep A for 1 and B for 2, and then you want to add them. That's what like initially computer was started, like very, very, very back in the day. Then computation started increasing. Computation started becoming less expensive, more compute. Then we have the computer that we have today. Andrej Karpathy is arguing, can we have a similar vision for LLM? And where the vision is, you keep LLM at the center, right? You keep LLM at the center, and at the center with LLM, you have RAM, which is the short-term memory or the context window. Then you have long-term memory, the disk system that can be used with RAG. Then you have the agent structure that you have with the tools, and then you connect it with internet, and when you connect it with other LLMs to have like a multi-agent setup or like a peripheral setup. And then you have your peripheral devices where you have got audio and video. Can we put together a system with all these things working towards a common goal, and that will ideally become your large language model operating system? This is quite a vision at this point. There are certain implementations available at this point. Those implementations are based on current understanding. They are mostly, let's say, LLMs plus function calling plus agents, multi-agent, more tools. That is what the current LLM OS is. It's not like a radically has a different total view altogether. And that's why if you see even in my framework that I've created, LLM OS is currently developing, and it is everything that we have got. The tools, the extended tools, the peripheral tools, with long-term memory, with short-term memory, with just one input from the user where it can run itself and then it can execute certain things. I think that is the future that we are heading. I'm not sure when we are going to do it, but if somebody says something AGI for me today, AGI could be like, this could be like the baby AGI. I mean, I don't I don't trust AGI as a concept anytime soon, but yeah, leaving the consciousness and all the other things out, I would say LLM OS is at the top where we can expect something closer to AGI happen, and all these things lead us up to there. So I wanted to keep this video brief, but this video is already going to be like more than half an hour. I wanted this to be like a crash course where you understand. If you don't know anything about LLM OS, maybe you have not taken any course. So this is going to help you to see how the future of LLM OS is coming and what led us up to there. And let me know in the comment section if you like this kind of content. I'll put together more. This took me a lot of time to create the framework, design, put it in a particular thought process to make it understandable. And this is basically what a lot of LLM courses offer. So I'm definitely looking forward to hear more feedback. And if you like this kind of format, subscribe to the channel. See you in another video. Happy prompting.